I will discuss to you the Memory Management Unit, or so MMU. Memory Management Unit, special hardware device used to take care of logical to physical address conversion. So we have the logical to physical address translation. So there's the CPU, the base register, base of reference address, the MMU, and the memory. So the 250 is the logical address generated by the CPU. The 2250 is physical address computed by the MMU. So there. That's the logical physical address translation as performed by the MMU. So we have basic main memory allocation strategy. So we have fixed partition memory allocation strategies. In fixed partitioning, the main memory is divided into a fixed number of regions or partitions. So this is the example of a fixed partition. You have the main memory is divided. And number 2, we have internal fragmentation. So internal fragmentation is a wastage of memory which occurs if the size of the memory partition allocated or processed larger than the size required by the process. So this is the illustration of a internal fragmentations. Example of internal fragmentation. And number 3 is the external fragmentation, a wastage of memory which occurs when there are partitions available but none are big enough for any waiting process. And this is the example of external fragmentation. This illustration of external fragmentation. And number 4, we have variable partition memory allocation strategies. So variable partitioning simply allocates the exact memory space needed by each process. So example is a computer system has 32 MB main memory with the operating system will find the first 4 MB. The following processes are inside the job key. So this is the example of variable partitioning. So we have the process size and execute time. The process is the P1, P2, P3, and P4. The size is the 12 MB, 7 MB, 8 MB, and 5 MB. And then the execute time is 10, 8, 11, and 7. So the P1 is size is 12 MB. The execute time is 10. The P2 is 7 MB. The execute time is 8. So P3 is 8 MB. Execute time is 11. So P4 size is 5 MB. So the execute time is 7. Okay. Ayan. So there's the process size, execute time. And this is the basic main memory allocation strategies. Illustration. This is the variable partitioning. There. Variable partitioning. Variable partitioning illustration and examples. So we have 3 placement strategies in variable partitioning. We have first fit strategy, best fit strategy, and worst fit strategy. And This is an example of a first fit strategy, best fit and worst fit strategy. So this is the example illustration. And we have in basic memory main memory allocation strategy, we have compaction. So compaction is the moving the process upward in main memory so that the free memory location may be grouped together in one large block. So this is the compactions example. This is the before compaction and this is the after. This is the before compaction and this is the after compaction. So see the changes of the compaction before and after. And in another topic is paging. Paging is a memory management scheme which process is allowed to occupy non-contiguous memory space. So processes are divided into equal size blocks called pages, while the main memory is also divided into equal size blocks called frames. So we have in frames we have free frame list. So a list of which frames are free or available for allocation. So we have, and the page table, a mechanism to keep track or where the opening system has placed the pages. So I will show you the illustration with paging. This is the illustration of a paging. Here's the and this is the page tables. Page tables. We have the process 1 and the process 2. Page 1, page 2. Paging is a paging. So we have logical address to physical address translation. So this is the logical address to physical address translation. We have illustration of a logical address. Paging is assumed the process whose size is 1 KB or 1024 bytes and whose page size is 64 bytes. So the minimum number of bits of each logical address is number of bits like 1 kilobytes, log 1 kilobytes divided by log. So this is the illustration of a number of bits, number of pages of process. Number of bits, log 1 KB slash log 2 is equals to 10 bits. So the number of pages of process is number of pages process size, page size. So 1 KB and 64 bytes equals to 16 pages. So paging number of bits for the page number field is show you the another illustration of a paging. There. There. Another type of page, another illustration of paging. This another type of illustration. This is a logical to physical address translation. And we have a page table implementation. So in page table implementation, we have option implementations of page tables. We have dedicated register, main memory, and cache memory. So that's all for all my topics. So thank you.